Hi, everyone, and welcome to Crazy 8 Day. All right, we did this in class, but in case you missed it, this is a very important lesson that you want to know about. So, Crazy 8 Days centers around this guy right here, something called the octet rule. What the octet rule says is that atoms in their valence electron shell want to have 8 valence electrons. If they can have 8 valence electrons, it means that it's much more stable. The atom is much more stable, and a stable atom is a happy atom, right? So atoms want to have 8 valence electrons, right? So it doesn't. That's where those, if you remember, that's where those electron or valence numbers at the top, right, of the periodic table, kind of like these little guys right here. That's where they come into play, right? If you're an atom and you only have 1 valence electron, you're not even close, right? But if you remember way over here, um, you know, um, with the noble gases, they all have 8 valence electrons. That makes them super, super happy. Well, aside from helium, but we'll get to that in just a second. Right, so they want to have 8 valence electrons. That's where the name noble gases come from, right? Nobles means kind of like kings and queens and their family from old, right? They'd hang out in their castles. They wanted to be where they are. They didn't want to be where you were, right? They don't want to be where people are around them except for their friends and family. That's why you have those big walls and everything for them, right? That's where the nobles lived. They wanted to be separate from the rest of us. Well, that's why when they were making the periodic table, they named those the noble gases, right? Because they had 8 valence electrons, they don't want to chemically mix, right? So the problem is not all the atoms have 8 valence electrons. If you don't have, if you don't have 8 valence electrons, you want to get them because the elements that have 8 valence electrons are the super popular ones. They're the ones that look like, oh, look, I have this great castle or this big house that I live in. They have all the toys like new motorcycles, the fanciest cars. They have their own planes. They have submarines. They have TVs that they measure in the size of feet instead of inches. I mean, they've got their own boats and yachts and things like that. Right? If you have 8 valence electrons, you are set for life. I mean, you're super cool. So again, right? That's where these valence numbers come in, right? Unless you happen to be one of the elements that have 8 valence electrons naturally, especially these guys down here, aside from helium, right? All the other elements, right, that don't have 8 valence electrons, right? They all desperately want to get it, and that's what chemical bonding is, right? That's basically atoms trying to combine together, trying to get 8 valence electrons. That's what the octet rule says. So if you have, let's say, 2 carbons, both of them have 4 valence electrons, right, which is that little 4 right here. Well, then they'll bond together and they'll have 8 valence electrons. Hence, very happy elements right there, right? So they don't all have their valence electrons like they'd want to. Let's say if you are elements, let's say in groups number 16 right here or 17, right? Well, you only have 6 or 7 valence electrons right here. You're so close to being in the cool club like these guys over here with their 8 valence electrons. You don't even know what to do yourself. It's kind of like winning the lottery, right? If you've ever been by somebody that's winning the lottery, well, it kind of goes like this, right? Let's say you have the numbers, you get the first number, you're like, ooh, that's exciting, but it's just one number, right? Second one pops up and you're thinking, well, that is nice, but you're trying to hold on to your excitement like, okay, it's fun. I got 2 numbers, but there's still a bunch more to go. But then the next number comes up and you're like, wait a minute, 3 in a row, something is afoot. The next number comes up, next to last number happens. It's right. You just one number to go, and when you get it, you just freak out. You have no idea what to do, right? Well, that's those elements that have 6 or 7 valence electrons. They are so close. They're kind of like in the phase, like right here. They're so close to having those the complete number that they just don't even know what to do themselves, right? So they want to have 8 valence electrons. Now, remember those electron shells. It does not matter which one you're talking about, as long as it has 8, because there could be lots and lots of shells. Now, if you remember, though, there's hydrogen and helium are the only two that don't follow this rule. They only have 1 electron for hydrogen, 2 electrons for helium, and they're so tiny with their 1 or 2 protons that all they can fit are just that first energy level right there. But because that first energy level only holds 2, both of them, if they have 2 electrons spinning around it, chemically speaking, they actually act just like an element, a bigger element that has 8 valence electrons. So hydrogen and helium, they're super happy if they only have 2 just because they're so tiny. But every single other element on the entire periodic table wants to have 8. So we covered elements that naturally have 8, aside from helium with its 2. They're all very happy. They're super stable. In fact, if you try to mix, let's say, krypton with any other element on the periodic table, It's like, no, thank you. I don't want to mix with anyone else. I'm complete. I've already got my 8 valence electrons. It's kind of like you after a ginormous, your favorite meal, and you just pigged out like crazy. Someone might offer you something else to eat that's amazing to eat, but you're like, I'm good. I'm all filled up and everything, right? Now, elements over here, they tend to be super reactive, like we talked about, because they almost have 8. They're kind of ravenous, like, got to get to 8 valence electrons and I'm almost there. So they're desperately trying to find any other element that's only got 1 or 2 valence electrons to combine with. And that's why, especially the halogens over here, why they're so violently reactive and so poisonous to us is because they almost have 8 valence electrons. They're kind of like crazy, like, I've got to get the last electron. What about the elements over on this side, right? If you remember over here on the periodic table, these guys are also super duper reactive. Now they only have 1, right, valence electron or 2 valence electrons. So for their story kind of goes like this. They are so far from having 8. They're like totally out of the super cool club and everything like that. They're so far away that they're desperate. They're also very desperate. They're like, we've got to do something to get close to having 8 valence electrons because everyone's making fun of us when we walk around on the periodic table here and everything. Right, so that's why these, especially group number 1 right here, tends to be so violently reactive because it only has 1 valence electron. And think about it, because it only has 1 valence electron, how many other elements out there on the periodic table are like, I could use 1 more valence electron, right? So they react with most anything, right? That's why potassium, simple little potassium in bananas, right? If it's pure potassium and you throw it in water, it explodes because it's just so reactive. It's so desperate to get closer to having 8 valence electrons. Now, there's one other section that you could have for it. Oh, yeah, well, here we go. Have my example of if you don't have 8 valence electrons, you get really moody and grouchy and everything like that, and it's like Angry Birds and everything, because you don't have your 8 valence electrons. What about elements that don't have 8 valence electrons, and they're kind of in the middle, right? They have, let's say, 3, 4, or 5 valence electrons. So it's not like you're like way out of the super cool club. You're not like you're way out, like super far, like not even close to the super cool club. You're in the middle. For those elements, they tend to be ones where they're still reactive, don't get me wrong, but they're not like super ultra reactive one way or the other because they're kind of like, I don't know, should I gain some electrons? Should I try to get rid of a couple of electrons? That type of thing. So those elements I call the squirrel elements. Kind of like the squirrel that's like trying to cross the road. It's like, should I go this way? Should I go that way? Should I go this way? Should I go that way? Until sadness happens and everything. Anyway, that's what the middle, those elements that are kind of in the middle are doing for us, right? So they want to try to combine to get, they want to try to combine to get those electrons that they need to try to get to 8 valence electrons. Hopefully this helps you out. There's no quiz for this video.